Okay, let me switch into present mode. I think it might help. All right, so our first video, we saw how research is influenced in psychology and how to apply experimental research. And obviously, if we were to run those experiments that we talked about whenever you watched last, I was going to say yesterday, you may have recognized that they wouldn't work the way we have them set up. So we have to talk today about research design and what are problems and solutions, and then we're also going to talk about measuring experimental research. So some statistics today. Okay, so I'm going to see if I can move myself. I think it'll be better if I'm over here. Okay, so problems and solutions in experimental research. So we're picking up the outline. So you might remember that we had a Roman numeral 1, a capital A, and then I think 1 through 4. So if we go with a capital B now, we should be good. So capital B is going to be problems and solutions in experimental research. And remember that when we don't have an equal sign, we don't have to write anything in additional to that, a description or definition. We're just writing what is there. Also remember that you should pause me when you do need to write in case I'm rolling a little bit too fast, okay? So when we look at experiments that are set up, we want to identify problems ahead of time and then solve them. So there's two major types of problems that we see: problems with our participants and problems with the researcher. And there's also two types of solutions, right? Problems for our participants, or solutions for our participants, and solutions for our researchers. So let's start with our participant problems. Okay. First of all, we might have something called a confounding or extraneous variable. So if you haven't gotten to that point where you're writing confounding extraneous variables with an equal sign, pause me and get that done. If you have been doing that, as I've been rambling on, I can define that for you. A confounding variable is any variable outside the experiment that can mess up the experiment. Okay, any variable outside the experiment that can mess up the experiment. Okay, so we talked yesterday, or the last time you watched a video, about context-dependent memory. We talked about a Halloween experiment. We talked about an aggression experiment with violent video games. So today I want to introduce a new one to you real quick. Let's say that we want to know if sugar makes children hyperactive. So our experiment is going to be done in a kindergarten class during a kindergarten party, and half of the kindergartners are going to get sugar and the other half are not, and we're going to measure the difference in their hyperactivity. Okay, now we're talking about, if we're going to set up the experiment just like that, obviously it would not be a good experiment, right? We have problems, we have confounding variables. One variable is it's a party, right? And kids are already hyper at a party. So it may be not the sugar that's making them hyper, it's the party atmosphere that's making them hyper. Secondly, and probably the biggest confounding variable, is that some of the kids are just naturally more hyper than other kids. So if you happen to end up with one group of kids that is naturally more hyper than the other group, then we can't measure whether or not it's because of the candy, right, or the sugar. So the biggest confounding variable, by the way, if you haven't written demand characteristics yet, you can add a little note to this, maybe with a parentheses, revolves around the dependent variable, right? We're measuring hyperactivity, and the natural hyperactivity that we see in kids is the biggest confounding variable here. So again, if you want to add in parentheses that the most damaging confounding variable revolves around the dependent variable, okay? Demand characteristics are another problem that can come into play. Imagine that if you were asked to be part of a psychological study and you were supposed to meet, in room 134 of the E building, and you showed up and there were 19 other people there. obviously your brain would start to wonder, what is this about? What is this experiment going to be about? And you're going to try to figure it out. And it's just kind of natural human nature to want to know what's going on. And that demand characteristic, I haven't defined it yet, by the way. That demand characteristic is what we call it, is going to affect the results. So we'll define a demand characteristic as the participants' expectations having an effect on the study. Okay, the participants' expectations having an effect on the study. So for example, if we're going to do the sugar experiment with fourth graders instead of kindergartners, and the fourth graders notice that some of them are getting sugar and some of them are not, they may figure this out. And the ones that get sugar might be more hyperactive in the study, not because of the sugar, but because of the expectation, right? It's almost like a placebo, right? That's going on here. The kids that don't get the sugar might be more calm because they might be like, oh, I'm not getting sugar right now. They are, so they're going to be more hyper than I am. So I figured this thing out. So that's what a demand characteristic is, okay? Now we can solve these things. We're not just going to quit, the study. So let's talk about solutions for participants. Okay, one we call counterbalancing or matching. And counterbalancing is basically just simply when we get rid of the confounding variable. Okay, so getting rid of the confounding variable is counterbalancing. So let's go back to the sugar hyperactivity study, right? The best way to compensate for this, by the way, is always to have a big sample and use random assignment. So if I have 100 kids and they are randomly assigned to either the experimental group or the control group, then their natural level of hyperactivity is not going to affect, it's not going to be a problem here because we're going to factor that out by having 50 in each group that were randomly assigned. But let's say that we only have like even 40. It's possible that 20 of them could be more naturally hyper than the other 20. So then what I might do is I might give a survey to the teachers of those students where I get an idea of how hyper they are and then make the two groups equal based on hyperactivity. So I would match the groups according to their hyperactivity as opposed to randomly assigning them because it's a smaller number, okay? Also, maybe I don't have a party atmosphere to counterbalance the variable. Okay, you may occasionally hear Oscar in the background. Very good watchdog. I'll show you him someday. So those are the, and here comes Bucky. Bucky sometimes gets in the way too. So if he ever steps on the computer, that could be an issue. He does that a lot. So I'm gonna try to get rid of him. So it's long nails. Okay. Okay, so those are demand characteristics and confounding variables and how counterbalancing can fix the confounding variable. We can use what's called a single blind technique to take care of a demand characteristic. A single blind technique is when we use deception to keep the participant ignorant about the study. So, the best way to maybe use a single blind in the sugar experiment is to give all the kids sugar. In quotes, only half of the candy doesn't have any sugar in it, and the other half does. It's like a placebo. If you haven't heard, hopefully you know what that is. You've heard of those things before. So that's one way we can do it. Another way that we can single blind a lot is to add different things to the study so they can't figure out what exactly is going on. So let's go back to we'll talk about the context-dependent memory in a second here. So single blind compensates for demand characteristics, counterbalancing compensates for confounding variables. Okay, the experiment the experimenter can also cause a problem in the research. We call it a researcher bias or experimenter effect, sometimes called experimenter bias or researcher effect. So, so the researcher problem that we want to address is called, it could be any of those combinations, a researcher bias, we'll say it for now. And a researcher bias is when the researcher unknowingly introduces a bias into the study. Okay, so let's go to the sugar hyperactivity. Let's say that I'm going to measure hyperactivity. My operational definition of hyperactivity is how many times the kid gets out of their seat. Well, if a kid kind of gets up but doesn't totally get up, is that getting out of their seat or not? Well, if the child ate sugar, the researcher might interpret it as getting out of the seat. If the child didn't eat sugar, then the researcher might interpret it as not getting out of the seat. See, the researcher wants their hypothesis to come true, so there may be bias that way. Let's say that they put the sugar group in one room and they're going to measure hyperactivity in that room and the non-sugar group in a second room. And then the researcher goes in there. The researcher might be more, what's the word I'm looking for? I want to say flamboyant, but maybe energetic or enthusiastic in the room with the sugar, because he or she wants them to be hyper in order to make the hypothesis come true. So they may actually get them more hyper with how they act. So those are different examples or ways that the researcher could bias the results. Okay. And then the researcher solution, remember that the demand characteristic solution we call the single blind, and it's keeping the participants ignorant about a certain part of the study. Well, in a research solution, it would be a double blind, or researcher that should be a solution. It would be a double blind technique where we keep both the participants and the researcher ignorant about key aspects of the study. So maybe we're doing the sugar hyperactivity experiment, and the kids who ate sugar are wearing a blue bracelet, and the kids who didn't eat sugar are wearing a yellow bracelet, but the researcher doesn't know who got the sugar. So, they had an assistant give half of them sugar and half of them not. And so when the kid does this in their seat, and the researcher is going to judge that, because the researcher doesn't know if they were in the sugar group or the non-sugar group, then they're going to be more likely to judge it without a bias. Okay. So hopefully, you can see how I'm sure that your mind was kind of running when we were talking about the other types of research, and you probably figured out that these aren't going to work, but we can always make them work or fix them to make them better. So let's apply these. Okay. Let's look at the two of the studies that we talked about the other day. Let's look at context dependent memory and violent video game and aggression. So the context dependent memory one, hopefully you remember, is the one where they learn in one environment and half of them test in the same environment they learned in, and the others test in a new environment. And we look at their test scores to see if one group scored higher or lower. So let's focus on that one first. So it'll be on the left here. So confounding variable, remember a variable that messes up an experiment, outside variable, is, what if one group was naturally more intelligent than the other group, right? If we are only doing a study with 20 people and 10 end up in one room and 10 end up in another room, there's a good chance that there's going to be a difference in maybe how much they study, how smart they are, all that type of thing that could be a bigger factor, right? So when we have a small sample size, that's going to be a problem. Again, if we're doing this with 100 people, then we can randomly assign and probably get rid of this confounding variable. But if we're doing it with a smaller sample, then we have to be more deliberate and we have to counterbalance it. So if we're going to counterbalance it, I'm not going to do it in the first test. I'm going to maybe do it on our second to last test or even last test, because I have a pretty good basis for the test. And what I'll do is I'll assign the groups based on previous test scores so that the two groups are equal. Or now I'll have a basis to judge that, this group went down from their average, that changed rooms, and the group that was in the same room stayed at or went above their average even. So that way we're counterbalancing, we're getting rid of that confounding variable. Remember, the confounding variable that is the biggest confounding variable is the one that deals with the dependent variable. In the context-dependent memory, we're measuring test scores, right? Test scores. So what affects test scores? Well, how much they study, their intelligence. So we have to get rid of that, okay? A demand characteristic. If I come in a room, let's say that we're in a classroom situation, I've got 20 students in there, and I say, okay, you 10, we're going to go to a different room and test. Then the 10 that are leaving the room, if they know anything about context-dependent memory, they might be like, oh, great, now I'm not going to do as well. So that's the demand characteristic. It's my expectation about what's going to happen that's going to affect my test result, right? So again, I would single blind for that. I would use deception. I would probably take all 20 out and say, okay, so it looks like we're going to have to split up because we're having a problem with the room. Someone else needs the room. You 10 are going to come into this room, and then I might bring the other 10 and walk them around and bring them back to the original room and just say, oh, you know what? I got a text from that teacher, and they're not going to use our room, so we're good. But I don't want to bother those other 10. And that way, the 10 that are in a new room think that the other 10 are in a new room as well. And the 10 that are in the same room won't realize that it's a part of an experiment, hopefully. Okay, so I have to use some deception. A research bias, let's say that I'm going to give an essay test, and I've got a pile of essays here that of the people that change rooms, and a pile of essays here of the people that stayed in the same room, right? Well, grading essays is kind of subjective, right? It's up to some judgment. So I might lean towards the group that stayed in the same room if I'm expecting them to perform better, and therefore grade them differently. So remember, we get rid of that by using a double blind. So we could use a multiple choice test because that takes away subjectivity. Or I can, if I'm just bent on using an essay test, I can have a third party grade them and say, you grade these. They won't know what group they were in and that type of thing. So what I want you to do now is I want you to pause me, all right? And I want you to do the right side of this chart on your own, okay? Just like we did before. And then we will see how you did. So pause me and try that right side with the problems and solutions. Okay, let's take a look at how we did. Okay. Okay, so confounding variable. Remember, the biggest confounding variable is the variable that deals with the dependent variable, and what we're measuring here is aggression. Remember, the hypothesis was, I'm having trouble moving myself. Okay, the wrong side. Okay, the hypothesis was if a person plays violent video games, then they will become more aggressive. So I'm actually going to just go back here. Okay, that's fine. All right. So the dependent variable is aggression. Remember, the biggest confounding variable tends to revolve around the dependent variable. So if we have a small sample, it's possible that one group is going to be naturally more aggressive than the other group. So that is going to result in their behavior more so than whether they played violent video games or not. Okay. So again, how are we going to counterbalance this? We can do a survey. We can survey the teachers to rate the students in aggression and make equal groups, just like we would have done with the hyperactivity, right? A demand characteristic. Well, if a kid plays a violent video game and then we give them a survey about aggression, they might be like, oh, I just played a violent video game. They expect me to be more aggressive. And in result, that will change their dynamic, right? Their natural response. So what I would do here is I would probably provide them with distractors. What I mean by that is I might bring them into the room and I might have them color something first. Like say, I want you to color a random picture that you think about. Okay. And then we're going to play violent video games. And then maybe we'll do a survey on aggression, and then we're going to go play pool. All right. And basically just kind of keep them from figuring out what this study was about. Is it about playing pool? Is it about the picture I drew? What's the connection? And basically, I can kind of deceive them enough to keep them from figuring out what the hypothesis of my experiment is. Okay, a researcher bias for this one. Again, if we're going to judge actions to be aggressive in a biased way, if we're going to watch aggression, so instead of doing a survey, we're going to watch and judge aggression. If two kids bump into each other, is that aggression or was it an accident? Well, if they were both in the violent video group, I might judge it as aggression. If they were both in the non-violent video group, I might judge it as an accident. So again, we would double blind for this by having a third party watch for aggression without knowing the independent variable, okay? Okay. So let's talk next about statistics in research, okay? So if you major in psych, you'll actually take a course called stats someday. It's not as bad as it sounds. And basically, it's but it's more complicated than we're going to present it. But I just want you to understand that we can't. Let's say that we're doing the context-dependent memory, right? And we have 10 students in each group in one study and 50 students in each group in another study. And in the first study that had 10 participants in each group, the mean changed -3 for the room change and +3 for the people who stayed in the room. And for the other study, where there were 50 in each group, the mean changed by 2 on either side. Is that significant? We don't know. We have to run it through a statistical analysis to figure that out. And when we do statistics, we're going to talk about statistics in the other types of research as well. But when we do statistics in experimental research, we call them inferential statistics because it's just what it sounds like. So we're going to define inferential statistics by saying inferring results, that's where the word inferential comes from, inferring results between the experimental and control conditions. And there's a formula for this that we're not going to worry about, okay? But what we look at is something called statistical significance, which is measured by what's called a p-value, okay? And the p stands for probability. That's where the p comes from. So statistical significance tells us whether or not, so we're going to define it as this, tells us whether or not the results are due to the independent variable. Okay, it tells us whether or not the results are due to the independent variable or if they're purely by chance. Okay, so was the change in test scores because of the change in rooms, or was it just happenstance? Okay, now the number that is significant to us is the 0.05 I have there, so 0.05 or less. Okay, 0.05 or less tells us that there's statistical significance. So that's what we're going to start our definition with. Tells us there is statistical significance because there is a 95% likelihood that the results come from the independent variable. Tells us there is statistical significance because there is a 95% likelihood that the results are because of the independent variable. Okay, so to try to simplify it, let's say that we run that study that we have the context-dependent memory and their test scores, and we get the results and we run them through a computer program, and it spits out 0.09. Okay, 0.09 is pretty strong. That's telling us that there's a 91% chance that these results were due to the room change. That was the independent variable, right? The room change. But 91% isn't good enough. 0.09 isn't good enough. So I can't publish this study. If it's 0.05 or less, so let's say it spits out 0.03, which means there's a 97% chance that it's because of the room change and not because of anything else. That is powerful, and that allows me to publish my results. And that also tells us then that if we change rooms, it's going to affect test scores. Okay. Now, again, the numbers that affect this are the size of the study, how big is the study, what the actual test scores were before and after. So there's a lot of numbers that go into it that we don't have to worry about. But that's basically how we measure it. Okay. So let's go back to slide 1, where we talk about research design and measuring experimental research. Okay. This is what we wanted to look at today, is that when we design a study, we have to look at problems, things like confounding variables and demand characteristics from participants and a researcher bias from the experimenter. And we solve the participant problems by counterbalancing or by a single blind technique. And we solve the researcher problem by using a double blind technique. We apply that so we can actively figure this out. And then we talked about the statistics of it. Now, as far as grading goes on this content, you're going to have a take-home kind of free response question, like an essay kind of question. We'll talk more about that when it's time. That's going to ask you about how to set up an experiment without, by solving any problems that might pop, identifying the problems and then solving them. The statistics piece, there might be a multiple choice question or two, but you're not going to have to figure any of that out. Okay. Okay, I just wanted to pop back and make sure that you knew that these are pages 31 to 32. So I'm trying to, because we are bouncing around just a little bit, and I want to make sure that you know what part of the reading this lines up with. So we should have a pretty good idea about experimental method now. We should be able to write a hypothesis, label variables, set groups. We should be able to look for problems and solutions within that research design. We should be able to randomly sample them in order to get the right participants to make it representative. We should be able to understand what random assignment is to either group to make sure that the two groups are equal and there is not a bias, especially one revolving around the dependent variable. And finally, we should have an idea what statistical significance means. So that was the goal of the first two videos that we set up.